Spatial filtering is a technique for modifying or enhancing an image. For example, you can filter an image to emphasize certain features or remove other features. In the last unit we talked about intensity transformations, which are commonly used to adjust contrast, brightness or saturation of images. The pixel values are modified in intensity, and the new intensity value depends only on the intensity value of the corresponding input pixel. It is not possible to sharpen an image by applying intensity transformations. If we want to sharpen an image, we need to apply spatial filtering. Image processing operations implemented with spatial filtering include smoothing, sharpening, and edge enhancement. Filtering is a neighborhood operation in which the value of any given pixel in the output image is determined by applying some algorithm to the values of the pixels in the neighborhood of the corresponding input pixel. A pixel's neighborhood is some set of pixels defined by their locations relative to that pixel, which is called the center pixel. Here Stephanie created a very nice illustration of a 5x5 neighborhood. It is also called a 5x5 filter or 5x5 kernel. The neighborhood in intensity transformations is only a 1x1 kernel. And that is the reason why intensity transformations don't work for image sharpening. The neighborhood is a rectangular block. If you filter an image, you move from one element to the next in an image matrix, and the neighborhood block slides in the same direction. So the sliding neighborhood processing consists of the following steps: selecting a center pixel with the values R and C, perform an operation that involves only the pixels in a predefined neighborhood about center pixel RC, letting the result of that operation be the response of the process at the current pixel, repeating the process for every pixel in the image. We talked about performing an operation that involves the pixels in a neighborhood. This operation might be linear or non-linear. Linear filtering is filtering in which the value of an output pixel is a linear combination of the values of the pixels in the input pixel's neighborhood. Linear filtering is illustrated in this picture using a 3x3 filter kernel. The intensity of the output pixel is a linear combination of the current neighborhood pixels. The equation is evaluated for all values of the displacement variables R and C. The image processing toolbox implements linear spatial filtering using the function imFilter. The fspatial function produces several kinds of predefined filters in the form of correlation kernels. For example, kernel types are average, Gaussian or unsharp masking, which you might know from Photoshop. Let us enhance the following ladies from Tissot in London. The first example shows how to filter an image with an 11x11 averaging filter kernel containing equal weights. The result is a very soft image. The second example illustrates applying an unsharp masking filter to the image. The unsharp masking filter has the effect of making edges and fine detail in the image more crisp. The image looks sharper.